Hi. At Hacker Future, I've been teaching the Node.js class a few times now, and I noticed some confusion about a particular part of one of the homeworks. In this homework, the students are supposed to build the API for a meal sharing website. And in this particular endpoint, the get API/meals endpoint, they are supposed to support different query parameters that will filter down the meals by max price, title, the creation date, and so on. The first thing is that the students start out by thinking that only one of these parameters should be supported at a time. But the text has been cleared up now to say that you should be able to support a combination of these parameters. And here's an example of a limit and a max price. And yeah, in this video, I will try to show how you can build a dynamic endpoint like that. I want to use this example of skoringen, where you can find shoes. So here, if I search for echo, you can see that if I specify the shoe size, now the shoes I get back will have to match with the search term still, but also with the size now. And if I select, like, let's say a color, now I have suddenly 3 conditions that must match. So that's similar to here, that not only one of them should be supported, but any combination of them should be supported. We're going to use Knex because that's what we have been using at Hacker Future Copenhagen, but other similar libraries also should be able to support the same concepts. Here I have taken I made a setup similar to what has been used at Hacker Future. So let's run the dev server like this, and let's see if that works. Okay, now things are up and running, and now let's hook this up to the database. Let me right here, we have a database that consists of 3 tables: shoes, brands, and reviews. A shoe has a brand ID, and reviews have a shoe ID, meaning that a shoe has many reviews. It has just a single brand like this, and the brands just has an ID and a name. Shoes also has price and primary color and so on. So let's just get this hooked up to begin with. Like that. Yeah. So this is basically how a row in the shoes table looks like. So we want to support a max price query parameter. We want to support a brand name parameter, meaning that I want to search and only find shoes by search brand. And we want to be able to filter by the rating. And lastly, also we want to be able to specify a limit. So let's just uncheck these here and start with the max price. You can see that there's a price here, and I want to say that the max price should be 700. and currently this is not supported, so we go back to the code here. And how should we structure this? Some students, they actually come up with the correct solution where they load all the shoes or meals, so to say, in records as a default term, and then do the filtering. But this is not this will not scale when you get to a very big database. So we want the database to handle that stuff. So the way you could do it is to build up the SQL dynamically. So we have the SQL like this, and then we have the where part, where you could have like the price should be less than or equal to the max price that the user specifies, and then you can dynamically add more and more things here. But the nice thing with Knex is that it can handle that for us. So let me show how you could do that. So if we define like a base query like this, which are just give me all these shoes, and then we want here we would then do like this, meaning that the query will not be executed until we get to this line here, and then we will respond. So here, let's just try this. This should work as it did before. And now we can say if there is a max price in the query parameters, we will then assign a new shoes query, but we will use the previous one and say where price is less than or equal to this one, this, and let's see if that worked. And yeah, now we're seeing only shoes that are less than that price. Cool. So what about the brand name? We can already see here that there's a brand ID on the shoes, so the name is on the brands table. So we would have to, so let's call this brand name here and say like this. We'd follow a similar pattern, but now we would need to join. So here we would say join with brands, and then we specify the foreign key and primary keys like that, and then we say where the brand's name. We're saying brands.name because the shoes also have names. See that here, that there's a name property. So where the brand's name is equal to request query dot brand name. Let's format that like this. And I believe there should be with the Nike like this. And we get back that yeah, actually we have more than this Nike shoe, but it also considered the max price. So it already did what we wanted, where it handles both parameters. So that's the nice thing with using something like Knex here. And you can see that we have more than one shoe from this brand. There is like a weird thing now with the ID is the same, and that's because there is a mix-up with the brand IDs and the brand name. So here we're seeing the brand name, but not the shoe name. So we can solve that down here by specifying what we want to select. We want to select, I'm not sure if this works, but let's try it out. All the fields from shoes, and we want the brand's name as brand name from the brands table. Let's see if that works. Yeah, so now down here we get the brand name. And as we saw before, it supports the combination of this, because the way it works is that this condition will be met because it has the max price, and this condition will be met, and because we keep on building on top of, keep on changing the query here, it will consider all the parameters. But there is a small issue here. We can see that we remove the brand name now. Say max price should be 700. This worked before, but it will not work now. Let's try it out. We've seen that this is just in waiting, and we see here that something went wrong. Unknown column brand's name in field list. And that's because if we don't specify brand name, then we will not perform this join, meaning that we can't then get the brand's name. And in this case, I would say that it's actually fine if we just always join with the brands table. So now let's try it out. Now we fix that. So now we have the reviews, which is a bit tricky because we have the shoe ID in this table, and we have the rating, which is a number. And so we have this same setup, minimum rating here, and we want to do something similar, but what should this be? So let's wait with this one. What we could do here is that we could join with the reviews, but instead we could also do a sub query, which is what I will do here. We will select the reviews. We'll do a group by on the shoe ID, and then we will have to have a condition that basically want to calculate what is the average rating of the shoe, because a shoe has many reviews, and you can't do that with the where, because where does not handle the aggregated fields. So we would need to do something like this and say average rating should be at least, and then we give the minimum rating here, and we will then say select the shoe ID, because now we can come here and say where in shoes ID, and then we give the rating query like that. And because we are matching on the shoes ID here, then we also need to, so that's why we select it over here, so we only get back the single value and not multiple columns like that. And yeah, that should work. So in terms of what the ratings are, we can't see them in the output, but I have them over here. I use this seed.js file to generate this fake reviews. So you can see here that we have some 3 point something and we have some 4 point something. So if we say minimum rating of 4, let's remove this for now. We see that we shouldn't be getting the echo ones. And that seems to be true. We can even try this out and say, get me the echoes where the minimum rating is 4, and we probably will get nothing back. But if we say 3, we will get back the echo shoes. And lastly, let's consider a limit. And you know, in a real case scenario, you always want to limit the number of rows that you get back. So the way we could do that could be something like this, where we say, if there is a limit, then we do, let me just check. Yeah, so it's just called limit, and then do like that. And if there is no limit, then we can just define it ourselves and say the default is, let's say, 10. And actually, you might even want to say, you know, if there is a limit provided by the user of the API, you know, it can at maximum be 100. Just so you can say like 10,000 and then overload the database. And let's try this out. So let's say we're searching for echoes, and let's just do it without a limit. So we're getting back 3, and if we say a limit of 1, we should only be getting 1 back. And yeah, that also seems to work. And all the combinations of these should also work. That's how you could solve this problem with a library like Knex. And if you were to use something like SQLize, it would probably look similarly. Just format it just so it looks a bit nicer. While you're doing this, you might run into issues. So a good way to debug that is to actually take a look at what does the SQL query look like. I believe you could do something like this. So let me run this one, and then we see here what is the SQL look like. We don't see the values provided by the user, we just see these, but you can see the structure of the query. I hope that that made things a bit more clear, and I also hope that you know, people outside of Hack Future learned a bit here. And yeah, if just let me know in the comments if I missed something or you have additional questions.